Okay, you guys, I thought we'd talk about another topic here in Chapter 2 that we didn't cover in managerial accounting that I thought could be useful for you. Throughput time. The throughput time is the time it takes one unit to make it through the production process. Alright, the formula for calculating throughput time is given here. The average number of units in work in process divided by the number of units produced each day. So it's a fairly simple and straightforward formula. What they're going to show is you can reduce your throughput time by reducing this average number of units in work in process, which really is just another way of saying if we can get the units through the production process, it's just a way of increasing productivity. So I made up an example here similar to an exercise in your book that you're going to complete for me. So let's look at this example exercise. Okay, McKay Industries produces 5,000 units each day. The average number of units in work in process is 100,000. Okay, so sorry, I had to move that over a little. Okay, if I want throughput equal to, okay, I haven't moved that around a little too much. Anyway, I want to divide the average number of units in work in process, 100,000, by 5,000 units that they produce each day. So that's going to be equal to 100,000 average number of units in work in process divided by 5,000, the number of units produced each day. So what that tells us is it takes 20 days for one unit to make it through the factory. Okay, now they go on in number 2 to ask if the same daily output, 5,000 units a day, can be achieved while reducing work in process by 30%. Determine the new throughput time. Okay, so it's the same formula, but to reduce work in process by 30%, well, 30% of 100,000, of course, would be 30,000 units. So in that example, I guess the first thing we should do is say, if we reduce our work in process by 30%, well, it was 100,000 units, okay, times 70%. We're going to reduce it by 30, so it'll only be 70% of what it was before. I hope that makes sense. If we reduce it by 30%, we can multiply the 100,000 units by 0.7, and that gets us to 70,000 units for our average number of units in work in process. Okay, so if we want to know throughput, we'll take that 70,000 divided by the average number that we're producing each day, which was 5,000. And that gets our throughput down to 14 days, down from 20. So what they're saying is really reducing the average number of units in work in process can really reduce your throughput time. Well, how do you do that? The book talks about just-in-time manufacturing, and just-in-time is a management philosophy that focuses on reducing waste in the production process, eliminating non-value added activities. For instance, if you're having to maybe walk 10 steps to get some materials used in the production process. If you could cut that 10 steps down to 2 steps, if we do that through the whole factory, you see how that can really cut production time. So just-in-time inventory focuses on this throughput amount and reducing it. You guys, after looking at this example, I don't think you'll have any problems with the exercise 214, your next homework assignment. Now, we've already worked quite a bit in managerial accounting, whether you took it with me or somewhere else, with, not managerial accounting, in financial accounting with our 3 inventory cost flow assumptions. But I thought I would mention those here. We might talk about them a little bit on the test, but I'm sure you've all worked through these several times before. We have 3 inventory cost flow assumptions, and they're used to assign a cost to units entered into the production process. That's raw materials units. These cost flow assumptions don't represent the literal flow of raw materials through the factory. Instead, there are 3 methods of assigning a cost to the raw materials inventory used in the production of finished goods when raw materials are purchased at varying prices throughout the accounting period. And a company would only use one of the 3 methods. What we're saying is, if we're buying raw materials at different prices throughout the year, we want to be able to assign a cost to the raw materials that we used in the production process. And these are just 3 different ways of doing that. It doesn't mean that that if we purchase the first one, like the first example, for instance, is FIFO, stands for first in, first out. Well, that doesn't literally mean that the first one's purchased or the first one's entered into the production process. It's just a way at the end of the year of assigning a cost to the raw materials that are left in inventory and to the raw materials that were used in the production process and became a part of finished goods inventory. So first in, first out, FIFO does stand for first in, first out. It assumes that raw materials are entered into the production process in the same order in which they're purchased. Notice that hinges on the word assumes. Doesn't mean literally that they were entered into the production process in the same order in which they were purchased. It's just a way of assigning a cost to those raw materials that we use during the year. And this results is first in, first out, in the items purchased at the beginning of the accounting period being included in finished goods inventory at year end, and the items purchased at the end of the accounting period being included as part of the raw materials inventory cost at year end. So the ones purchased at the beginning of the year were said to be entered into the production process. The ones purchased at the end of the year would still be included in raw materials inventory. Now if we go with LIFO, that acronym stands for last in, first out. It assumes the raw materials entered in the production process are the ones purchased most recently. And we know, and literally, that's not possible, right? We can't use raw materials purchased in December. We couldn't have used those in January. So it's not, again, it's not a literal flow. It's just at the end of the year, we want to assign a cost to the raw materials that were used in the production process and became a part of finished goods. And we want to assign a cost to the raw materials that are left in raw materials inventory. Just 3 different methods for doing that. So LIFO results in the items purchased at the beginning of the accounting period being included in raw materials inventory at year end, and the items purchased at the end of the accounting period being included as part of the raw materials that became a part of finished goods inventory. The third one is just a kind of a hybrid of those 2. It just takes an average. Moving average method determines an average cost of the units, of the items in raw materials inventory after each purchase. So if we bought if the first purchase was at $10 a unit, 100 units, the next purchase was $12 a unit, 100 units, then our average cost would be $11. So once we determine that average, and it's weighted, in my example there both purchases were 100 units, that wouldn't necessarily be the case. So we would weight if we purchased 200 units at $12 each, they'd be given a heavier weight in the average than the 100 units purchased at $10 each. We'd take a weighted average, really. Then the raw materials entered in the production process are costed using that average price per unit. All the materials entered would be entered at that average cost. You guys, I just thought I'd go back through those as a review. I'm sure you've worked with them quite a bit already. But just complete these two exercises here in Chapter 2, and we'll have you a test up pretty soon. If you have any questions or concerns, please be in touch with me, and thanks a lot. Hope you have a great day.